My name's Connor Harris. I'm a production engineer at AISIN. I started about 8 or 9 months ago. Probably like my sophomore year of high school. I didn't really know what I wanted to do, but I took a CAD class, like a drafting class, and we would do all kinds of stuff out in the shop. We had a CNC router, multiple 3D printers, and a laser etch. And it was either my sophomore or junior year, we got the laser etch in, and the teacher kind of just showed me what he knew, like what he read from the manual, and then kind of just let me loose on it. And so, I mean, it was me and a $15,000 laser machine, and I just kind of got to run free with it, and I had a lot of fun figuring it out and seeing what it could do and moving forward with that. We try to have new ideas, but at the same time, we're trying to upkeep the things that we already have going. A lot of the job is making systems that aren't perfectly designed to work together. It's kind of like being a translator, but instead of for 2 languages, it's like for 15. So we've got so many different systems that, like I said, aren't designed to work together perfectly, and we kind of have to do our best with what we can to make everything come together and accomplish the goal that we're going for. Generally, it's little things. Get out on the floor, operator's got a small issue, it's something that they haven't had a lot of exposure to, and it's something I've got an answer to real quick. But outside of that, it's probably just lost time. So anything that could be more efficient, anywhere we're losing time where the line could be running, it's not anything like that. I don't know if this perfectly answers the question, but the rest of the team, like, obviously when I first got here, there's new hire information and there's documents I can go through to kind of brush up on some things if I'm unfamiliar, but there's nothing better than getting one of the older engineers that have been here for 10, 15, 20 years and just getting behind them and watching what they're doing, asking them questions. Capacity up, line 10 and 11. So over Christmas break, when everybody was out, we, with obviously preparation beforehand, brought in 2 machines and completely took the line apart, broke all the communication cables, and put those 2 machines back in, put the line back together, and got everything back in. So we've got a capacity up. We got a little more throughput on that line. I'd say we took our cycle time down 2 or 3 seconds, which is huge when it's 15 seconds. So I'd say upped our capacity probably 10 to 15%. Open-mindedness. If you hear somebody tell you what a problem is, you can't show up already thinking you know what the answer is, for a multitude of reasons. Mainly being the person that told you what's going on may have misdiagnosed the problem. But if you get into a machine and you've already told yourself that it's a mechanical issue and you're in the machine with wrenches and Allen wrenches and pulling things out, replacing parts, it could be an electrical issue. But since you didn't take the initial steps to kind of diagnose, you just went off of what you heard, you're hours behind where you could have been if you had done the initial steps right. The most challenging thing is efficiency. So you could say efficiency, but as far as order of importance goes, I think if there's an idea and it's immediately not safe, it's out. So I think safety has to be first. And again, counterintuitive, quality has to follow, because if we're not making good parts, we might as well be making no parts. So efficiency 0. So then we have quality. We've got to make sure everything's the way it's supposed to be, everything's in tolerance. And then after we get past safety, we get past quality, then it's efficiency. So that's where the real hard work comes in. We're trying to dial down on the process that we've made after it's cleared safety and quality.